Okay, so this is part 2 of lesson 2.3 in grade 11 functions. We will continue to look at more examples of factoring. So example 3, you have another trinomial, but this time instead of seeing one single variable, you see 2, and you cannot common factor 3p squared or 11pq and negative 4q squared. Therefore, you need to think a little outside the box, and remember, factoring is the opposite of expanding. So the question really is, well, what multiplies together will give you 3p squared? 3p times 3p, right? At the same time, you also think about the last term because it's formed by multiplying the last terms in these binomials together. What will give you a q squared when multiplied together, or negative 4q squared? Well, let's forget about the negative 4 for a second, but to get q squared, I must have q times q. So once you understand this question is no different from factoring trinomials where the leading coefficient is not 1. So your product is 3 times negative 4, so the product is negative 12. The sum is 11. Find those two magic numbers. That will give you this right combo. So it turns out to be negative 1 and positive 12. Use the leading coefficient as the numerator of the funny fraction. So 3 over something, 3 over something. What goes under in the denominator? Negative 1 and 12. I can reduce 3 and negative 1. But I can definitely simplify 3 over 12 to 1 over 4. Remember, these becomes the coefficients and the constant term in those binomials. So 3 over negative 1 now becomes 3p minus 1q. Don't forget that q. And then 1 over 4 becomes p plus 4q, just like that. Question B. When I look at 4y squared minus 9 times x plus 3 squared, I see one term, 4y squared, minus a second term, 9x plus 3 squared. So it's not a trinomial. There are no common factors. What do we do? Well, the only special pattern that we know so far that has two terms is a difference of squares. So, can 4y squared be square rooted? Yes, 2y. Can 9x plus 3 squared be square rooted? Oh yeah, square root of 9 is 3, square root of x plus 3 squared is just x plus 3. So this is a difference of squares. So you just apply the rule. Square root of the first term plus square root of the second term. Don't worry about the brackets for now. We'll clean that up later. Form is more important. And then multiply by square root of the first term minus square root of the second term. And now it's cleanup time. So I can expand 3 into the x plus 3, so it becomes 3x plus 9 plus 2y, and in alphabetical order, it looks like this. Second brackets, I have negative 3 times x, negative 3x, plus 2y, negative 3 times positive 3, negative 9. For good form, we prefer not to have any leading coefficient that is negative. So I'm going to factor out the negative sign from negative 3x in your second brackets. So when I do that, the negative sign goes outside, and then we just switch signs of 3x, negative 2y, plus 9. And then here is just 3x plus 2y plus 9 from the last line. Okay. C. Once again, I have a binomial. It's a really long binomial. First term is 4m times n minus 1. The second term is 3 times 1 minus n. And you go, well, hold on a second. I don't see anything that looks exactly the same. And you're right. They're not exactly the same, but we can take a look at n minus 1 and compare that to 1 minus n. The signs of these terms are the exact opposite. So now if I factor out a negative 1 from 1 minus n, 1 will turn into negative 1, negative n will turn into positive n. And guess what? We can now see more clearly that among the two big terms, n minus 1 is a common factor. So now divide 4m n minus 1 by n minus 1, you get 4m. Divide negative 3n minus 1 by n minus 1, you will get negative 3. And you have fully factored this binomial. Question D. It looks long and complicated. You can try factoring t squared plus 4t plus 2 and 3t squared minus 6t plus 17. And then it may give you the factored form. Or you go, well, it's just as much work as expanding everything, simplifying, and then performing the factoring. So sometimes expanding and factoring is a faster way for some. Okay. Lastly, in your last example, we're going to discuss something called grouping. So when you look at a long polynomial, you may go, well, I don't really see a common factor among every single term. But if I strategically group some terms together, I may notice that I can find some common factors among the groups and then eventually write this whole polynomial in factored form. So all multiplications. So when we do grouping with 4 terms, I guess most of you will say, well, we can group the first 2 terms and the last 2 terms together and see what happens. So if I group the first 2 terms together, so cover this green part for now, a common factor for ax and cx is x, and the rest of the terms will be a plus c. Ignore the red part, focus on the green part. Your common factor is y, and you will have a plus c as the second factor. So now we're on this line in the second line. How many terms are there? We're down to 2 terms. What's the good news here? I see a plus c in both terms. So a plus c is a common factor, and from the red term, I will get x. From the green term, I will end up with a y. So a plus c times x plus y. And now there is no add or subtract between these 2 brackets. We are talking about one single term, which is the factored form, because it's multiplication of ax squared plus cx plus ay plus cy. Can we group the polynomial question B using the first 2 terms and the next 2 terms? Absolutely. Y cubed plus y squared, common factor, y squared, and you get y plus 1. Now you kind of know that, well, I kind of want to see y plus 1 because I want to factor that out in my second group. So when you're just trying to decide what to factor out from the last 2 terms, is it positive 9 or negative 9 that we should take out? We have to take out negative 9 so that you will have y plus 1 as a factor. So now y plus 1 is a common factor, and then you will have y squared minus 9 as the second factor. But wait a minute, y squared minus 9 is also a special pattern on its own. It is a difference of squares. So factor that as y plus 3 times y minus 3. That's it. Do we always group by first two terms and last two terms? Of course not. You can always, as I said, do this strategically. Take a look at C. I have a Q sticking out here, and there are no Q's in the last three terms. So if I do group 1, group 2, that's not helpful. But if I factor a negative sign from the last three terms, like that, I notice that I have a perfect square binomial. So p squared minus 2p plus 1 in factored form will become p minus 1 squared. And what have we got here? A perfect square, q squared, take away an other perfect square. It is a difference of squares. As a result, apply the rule. Square root the first term plus square root the second term times square root the first term minus square root of the second term. And now we just want to clean up our signs and brackets. So expand, expand, and remember we prefer not to have this negative leading coefficient, so factor the negative sign out. From this bracket you get positive p minus q minus 1 times p plus q minus 1. And that's all the factoring that you will need to know in grade 11. Now you can move on and try doing those homework questions listed on the first page of your handout. Good luck!